Hello, this video is about one of the simplest radios that can be built. It's just an MCU and a few discrete components. A mobile phone or a computer is used as a serial terminal to control the radio and for power, 5 volts from the USB. It's a multi-mode receiver that goes up to the 20 or maybe 15 meter band. Transmitter for now is CW only. Maybe in the future someone will add other digital modes. Power is 4 watts. There's a better description in the links below. With about 20 euros and a few hours of work, it could be a fun project for people that want to start with ham radio or broadcast listening.
You need to be your own boss. Keep it up. When I feel better and I can move around, I'll take my friends and bring them to your store to shop. Really?
Всего 70. За историю конкурса юношей больше, чем девушек. 40 против 30.
Japan America 5 Whiskey November Hotel. This is Italy Zulu ASCII Delta Echo Papadalo.
Yeah, Kyoto Albert San Bonoveranda. Italy Zulu 8 Delta Echo Papa. Japan America 5 Whiskey November Hotel. Thank you for the such a nice people. Gracias.
India Mike. Victor Echo 2, Italy, Mexico. Contest, Victor Echo 2, India Mike. Victor Echo 2, India Mike. Okay, 73, send greetings from Qatar. Alpha 71 Alpha. CQ contact, this is Alpha 71 Alpha, Alpha 71 Alpha.
Okay, let's try a QSO. I'm powering the radio. This is its USB cable. This is an OTG adapter, because in this case a communication is with the phone as a host and the radio is a slave. Receiver is already powered. I need more current because I'm going to transmit. This is a USB battery. It is required only for transmission. For reception, power from the phone is enough. So let's start the terminal program. This Droid Term app is the only one I know of that allows to move the cursor around with an escape sequence. The other terminal for Android I know of just write from left to right and from top to bottom, and this is not as good as this. I will start the terminal. This is the main interface to the radio. Now in CW I will look for a clear frequency. Yes, for example 7010.5 seems to be clear, and it will just be a quick test. And the first thing I will try to do is to receive myself on a web SDR receiver. This is a map of the receiver of the Kiwi SDR receiver network. There are all, this is just Europe, but there are all about the world. For example, I'm right here in the north of Italy. Yes, Parma is here. I will try, for example, to receive myself in Cordova, Spain. Open it in a new tab. Yes, this is perfect. I will switch to transmission. Narrow band reception, better. Anyway, I will just press it. This is my signal here. Now some information about the radio. Input signal from the antenna goes to a bandpass filter here. It can be changed. It's on two connectors. I have one for 0 to 4 MHz, another for the 40 meters band and another for the 20 meters. Then the signal goes to a preamplifier. It is done with two bipolar transistors. Originally it was intended to use an MIC amplifier on the board, but it was not stable because on higher frequency like 1 gigahertz and higher, it has too much gain and it never worked as it should. So I decided to have this, and in a later board it will be integrated. Then the signal goes to the ADC of the STM microelectronics CPU. The CPU can sample up to 9 mega sample per second, so it can more or less receive up to 4 megahertz. For 40 meters, which is at about 7 megahertz, it undersamples the signal, and the input filter selects the slice of frequencies that we are interested in. So this should be as sharp as possible, and it is a limit of undersampling. Then there's not much more, because we have a crystal oscillator here. This is for the transmitter. We have a driver here. This is a power MOSFET. This is a pi network for adapting impedance, because it is working at 5 volts, and since we have 4 watts, we should have about, I don't remember exactly, but something like 30 or 40 volts peak to peak. And so it must adapt the impedance of the transmitter to the 50 ohms of the output. This is the USB connection that controls everything. Signals from the USB goes directly to the CPU. We don't have any USB to serial converter, because this conversion is done internally by the microcontroller, and everything happens inside the software of the MCU. It is based on the work done by Alberto I2 PhD. Some years ago he did this on a M4 CPU, which goes up to about 1 megahertz. Now with this more modern CPU, we can go much higher in frequency, and also the CPU clock is it is sold for 480 megahertz, but I overclock it up to about 600 megahertz, and it looks quite stable even at this frequency. Then we have another USB cable here. This is just for the power, because we can't have all the power for the transmission with a single USB line. So we have two, and only when transmission is required. This is just a prototype. As you can see, there's a lot of free space, and it is used for other circuits. I will try later. For example, it can be used as a dual conversion, or a single conversion receiver with a RF mixer, which should be here, and then we have a crystal filter, and then at a 10.7 megahertz the CPU just do the SDR receiver on a fixed frequency, and so we avoid most of the limits of the underconversion receiver. Most of the things happen inside of the MCU. It is based on the work of Alberto I2 PhD. Several years ago he made a receiver which was based on a M4 ARM chip that was available at the time. Now with the H7 component, performance is much better. I checked this chip because I was interested in the ADC and the DMA part for a professional work I'm doing, and well, I think that it is really powerful. The development environment is powerful, and it's not so complicated as people that use Arduino are used to say. I think that it's much easier to use a complete development environment with a debugger, with some tools to initialize the peripherals than the Arduino, which is quite frankly, it is frankly very limited. This will be the next release of the PCB. I hope it corrects many things I forgot in the first release. It's more or less the same thing. We have 3 sets of bandpass filters that can be selected with these jumpers here and here. It should be about 20 euros of components, so I think it's quite affordable, and it can be done I think in a few hours. So thank you very much for the attention, and I will provide another video when this PCB will be ready. Thank you, bye bye.